Hello friends, welcome to the video lecture series on artificial intelligence and machine learning. I am Dr. Dafda, and in this 25th video class of AI/ML, we will understand measuring problem solving performance in artificial intelligence. Starting with the name, what does measuring problem solving performance means? See, it refers to evaluating how well a search algorithm performs in solving a problem based on factors like efficiency, accuracy, and resource usage. Next question that comes in mind is, why is it important? See, it is important as different search algorithms have different strategies and weaknesses, and hence measuring performance helps us choose the most suitable algorithm for a given problem. Also, what are the key aspects of evaluation? See, we analyze completeness, optimality, time complexity, and space complexity to determine an algorithm's effectiveness in solving AI problems efficiently. In this video class, we will break down these factors and understand how they impact AI search strategies. Okay, so let us start. Let us understand the criteria for evaluating search algorithms. See, before designing or choosing a search algorithm, we must assess how well it performs. So there are 4 key evaluation criteria. Number 1 is completeness, which ensures that the algorithm does not miss a solution when a solution exists. Number 2 is optimality, which checks whether the algorithm finds the best possible solution. Number 3 is time complexity, which measures how fast the algorithm finds a solution. And number 4 is space complexity, which refers to how much memory the algorithm needs. Remember, some algorithms may be fast but require a lot of memory, while others may be slow but find the best solution. Okay. See, time and space complexity help us understand how resource intensive a search algorithm is. In theoretical computing, complexity is measured based on the size of the search graph, that is, the number of nodes and number of edges. So, state space graph size is equal to modulus of V plus modulus of E, where V is equal to vertices or nodes and E is equal to edges or links. And in AI, search graphs are often implicit and infinite due to dynamic environments. So in artificial intelligence, complexity depends on branching factor small b, which shows how many child nodes each node generates, depth small d, which shows the steps needed to reach the nearest goal, and maximum path length small m, which shows the longest possible solution path. So time complexity is equal to number of nodes generated and space complexity is equal to maximum number of nodes stored in memory. That is, time complexity is measured by counting nodes generated and space complexity is measured as the maximum nodes stored. Okay, let's go ahead and understand search cost and total cost. See, evaluating a search algorithm's efficiency requires looking beyond time and space. Search cost is just the effort to find a solution, while total cost considers both search effort and solution quality. That is, search cost is equal to time plus memory used, while total cost is equal to search cost plus the path cost of the final solution, right? So you can say time plus memory plus kilometers, how many kilometers it traveled, right, for going from Arad to Bucharest. So in a route finding problem, search cost is equal to computation time to find the path or best route, while solution cost is equal to total distance of the route taken in kilometers. So total cost will be combination of search cost plus solution cost, that is time taken to compute plus distance of the route. So obviously, if an algorithm spends too much time searching for a better route, it might waste resources, and artificial intelligence agents must balance computation time and solution quality efficiently. Okay. So to summarize, why measuring performance matters? Measuring the performance of search algorithms is crucial in AI to make informed choices. We use 4 main criteria, that is completeness, optimality, time and space complexity, and each helps us to judge how effective and practical an algorithm is. However, in many real-world problems, we must balance speed, memory and solution quality. So knowing when to use a simple, fast method or a slower optimal one helps us build intelligent agents that can solve problems effectively in different environments. So performance measurement is not just theory, it guides the real world applications of AI. So that is all for this video class. Thank you very much.